All right, welcome back. So if you're watching this, don't look at that word. It should be Wednesday, June 3rd if you're following the recommended calendar on the syllabus. But please do that because that's when the homeworks come out. All right, so chapter B, we have B.3, and this is on rational expressions. So what is an irrational expression? So we can see this kind of like when we talk about linear that has the word line in it. This has the word ratio. A ratio is a fraction, right? So a rational expression is a fractional expression. And this is, when we say fractional here, we're talking kind of like not in really math terms, but in like English terms. Remember, math is kind of like a different language that we're trying to learn right now. So rational means ratio, or fractional means something very, very different, but it kind of gets the point across. So where the numerator and denominator are both polynomials. So some examples, I thought someone's car alarm was going off and I'd be like, really? Are like, let's say, usually I would ask you, like, what are your favorite ones? But like 4x plus 7 over 3x. X plus 1 over x plus 2. And then I can go farther, like x squared plus 2x plus 1 over x squared minus 1, something like that, right? So the reason that we're talking about rational expressions is so that we can simplify them. So if we scroll down here a little bit. So simplifying rational expressions. To simplify rational expressions, we factor both the numerator and the denominator, right? So in B.2, we just kind of learned about different ways to factor, doing like pulling out common, I recorded last week, grouping, the AC method, and pulling out common factors. There we go. Right. And using properties of factors that using properties of fractions to cancel out common factors. So that property specifically roots back to, remember, factors are things that are multiplied, terms are things that are added and subtracted. When we multiply fractions, we can do something, we can do the opposite, we can pull them apart. So if I have a times c over b times c, well, that's the same as writing a over b times c over c, right? Because multiplying fractions, we multiply the numerator, multiply the denominators. Well, then anything over itself is just 1. So this is like times 1, which anything times 1 again is just itself. Oops, not c. Right? And the key thing here is that c doesn't equal 0. 0 over 0 is undefined. We don't really know. We don't really have any idea for that. Ask your phone if you have an Apple phone to what 0 divided by 0 is. It gives you a fun little thing. All right. So a, b, and c in this case are factors, right? Things I'm multiplying together. X plus 1 times x plus 2 divided by x plus 3, something like that. All right. So let's work on this quick example. So simplify x squared minus 1 divided by x squared plus x minus 2. So x squared minus 1, if we remember what that looks like, x squared minus 1, which is a square, 1 times 1. So that's the difference of squares. So I know that x squared minus 1 over x squared plus x minus 2. If you want to do it one, not numerator then denominator first, or both, that's fine. Just please always show your work. And we can write, oh, x, that's going to be x plus 1, x minus 1, because we know the difference of squares now. Didn't like that line. And then this polynomial isn't too difficult. Things that multiply to -2 and add to 1. 2 and -1. So it'll be x plus 2, x minus 1, right? Because then I would get, yeah, perfect. All right, cool. So now we can see that I have something like up here, Where's my pointer? Let's do green. So right, so this would be like A, this would be B, and here's C and C. We also don't always have to just pull it out and then call it 1 and blah, blah, blah. We sometimes can just also, with practice, can see that we just cancel them out. They cancel each other out. They're not actually, they're canceling each other out to create 1, like we see up here, and then 1 times anything is just 1. So that leaves us with x plus 1 over x plus 2. Beautiful. Sorry, my chair is squeaky. I think that's it. Right, and I'm gonna box my answer, and we're done. All right, now let's do this next example. B minus A over A squared minus B squared. Well, this is difference of squares yet again. B minus A, I would call that, what's it called? You probably know it already because you just watched the lecture before. Irreducible. Other than pulling out, I can always pull out a negative out of anything, but pretty much irreducible. I can't factor B minus A or A plus B or something like that at all, right? So A squared minus B squared, we know that's going to be, so B minus A isn't going to do anything right now. That's going to be A minus B, A plus B. So I said B minus A is irreducible, other than I can always pull out a negative out of anything, but that's not really a common factor. Just kind of like how you can pull out 1 out of anything. It's kind of like, woohoo, but like, meh. So I want to be able to cancel these 2 right here, this guy and this guy. So I can write it in 2 different ways. So I can either pull out a negative on the top or the bottom. I usually like letters to go alphabetical. So I'm going to pull it out of the top. So it's going to be A minus B, A minus B, A plus B, and the denominator. All right. So now when I cancel these out, I've seen this a few times. These are canceling out to be 1, not 0. So there's going to be a negative 1 on the top, A plus B. Think of it also just like a hidden negative 1 right there. So that negative 1 is left over. I've seen so many times where people put 0. They're like, oh, there's nothing there anymore. It's like, okay, well, if I think about it as, oh, negative 1 over, I need to be able, when I do like A minus B over A minus B and go back to where I started, I need to be able to go back. If I put a 0 here, well, 0 times A minus B is 0, and I don't get here anymore. I would get 0. So that disproves that it's 0. Okay? Okay, I don't need this right here. And y to negative 1. Kind of like a placeholder. 0 isn't a good placeholder when we're talking about multiplication, because it just makes everything 0. It's a very selfish number. All right, cool. So now that was just simplifying expressions, which is super fun. We've talked about multiplying and dividing fractions. Remember, I didn't know how to divide fractions until senior high school. And we can do the same thing with rational expressions, just like we can with rational numbers. So rational expressions are just fractions, so operations work the same as they do for fractions, blah, blah. To multiply rational expressions, we use the following property of fractions. So if I have x over, ooh, why did you undo that? X over y times a over b, we already talked about this. This is going to be x times a over y times b. Additionally, to divide rational expressions, we use the following property. Remember, this is keep, change, flip. So if I have x over y, and this is where the division sign is mostly used, because writing fractions and numerator and denominators gets wild, and it's really easy to see using this division sign. So I'm going to keep x over y. I'm going to change the division to multiplication sign, which in this case is just a little dot. And I'm going to flip my second fractions. Instead of a over b, it's going to be b over a. Alrighty. And now I can use that first property that I just learned. We're relearning. Oh my goodness, what am I doing? I also don't need this dot here. Beep. There we go. All right. So multiply across, keep, change, flip for division. Oh my gosh, you're so squeaky. I switched it, but then we like moved things around. Okay, cool. Keep that up for a second. So multiply and then simplify. So, okay. Let's do that. Since we're simplifying, that involves factoring. I would not, and I highly recommend not like foiling these things after you've multiplied them together. Keep them separate, okay? Because you're gonna then just factor them, and it's not gonna factor anything new. I believe for polynomials, there's factorization's unique. I think so. I'm like 99% sure, but I'm not a pure mathematician, and that feels like something a pure mathematician would know more about. So I'm gonna have, when I multiply across, I'm just gonna smush everything together, right? So instead of x minus 1, x plus 2, this is where parentheses are your friend. X squared, what, plus 4x plus 4. X squared plus 2x minus 3. All right, I'm not going to foil these, right? What's the point? I need to factor them. So if I foil, then I need to factor them. But it's technically already factored. I just have x minus 1 and x plus 2. Those are both irreducible. So I'm going to keep them. And then x squared plus 4x plus 4. If I go over here, that's a little too far. If I kind of go x squared plus 4x plus 4. I want something, since a is 1, I can just look for things that multiply to c, which is our constant. If you remember back to the AC method, I want things that multiply to 4 and add to 4, 2 and 2. So that's going to be x plus 2, x plus 2. And then for x squared plus 2x minus 3, things that multiply to negative 3 and add to 2 would be x plus 3, x minus 1. Beautiful. It won't always happen. In mathematics, we really like patterns. I'm just going to put these in while I talk. But it's a good sign if you factor one of these polynomials and one of the things in the numerator, or if you're factoring the numerator, something in the denominator is the same. That's a good sign. Let me just like kind of box that off. So that's scratch work. Great. And so now I have x minus 1, x minus 1. They cancel out, create a 1. Same with the x plus 2, x minus 2. And what if you want to just quickly add that there's a 1 right there so you don't forget that it's not going to be 0 in the numerator. We're going to have 1 and whatever's left over. So there's a second x plus 2, x plus 3. And we're done. Pretty fun. You also could have written x plus 2 squared in the denominator, since there's 2 of them. That's fine. It's similar to how we worked with simplifying expressions when it's like x squared over x to the negative 3, something like that. But now it's x plus 2 is that something squared. All right, and that's that problem. Okay, pause if you need more time. Whee! So now we're going to do a division one. Super fun. So right, divide, then simplify. So I'm going to keep 4 minus x squared over 6, change this to multiplication, and then flip it. So it's 2 over x minus 2. Great. So I'm going to then multiply across, then I get 2, 4 minus x squared. I just put the 2 on the left rather than the right, just because that's how you write expressions. And then 6x minus 2. And then actually I can kind of go ahead and 2 over 6 reduces to 1 over 3. So that leaves a 3 in the denominator. So now if I want to go down here, x minus 2, that is irreducible up to pulling out a 1 or a negative 1. Mostly pulling out a negative 1. Pulling out a 1 does nothing. So now we have a difference of squares. 4 is a square and x is a square. But now the 4 is before the x. So that's going to look a little different than what you're used to. So be careful. A good way to check if your factoring works is to multiply it back out again. So that's going to be 2 minus x, 2 plus x. 2 minus x, 2 plus x. Over 3 x minus 2. But none of these things are the same. It's just like that one before where I have a factor, and it's something minus something, and it's flipped. So I need to pull out a negative 1. I'll like box this so you guys don't think that that is and part of like what it's supposed to be equal to. Negative x minus 2, 2 plus x, which is also the same as x plus 2, but just for consistency's sake from the first step, we'll stay here. Perfect. And then that negative go through and get 2 plus x over 3. Is that the right answer? Yay! And if you want to distribute that negative as well, so you get negative 2 minus x, perfectly fine. Just make sure when you distribute it, you distribute it to both of them, not just the negative 2, because then you would give a incorrect answer. It's not more simplified to distribute the negative or not, in my opinion. Okay, so that was a quick example on dividing and multiplying expressions. That's why we talked about factoring right in the section before, because it's a huge part of simplifying. It's all building on itself. All right, cool. Sorry if my head is now blocking the answer. I never know where it is. Okay, so adding and subtracting rational expressions. So we kind of already talked about this a little bit, but this is more technical. So similar to fractions, we need to find the least common denominator. And sometimes we talked about, right, if it was like 2 and 7, the least common denominator is going to be when I multiply them together. So it's going to be 14. I don't know why that took me so long to think of. So, but it's not always going to be true. Like, I can't think of anything right now. I always think of, is it like 4 and 6? Yeah, 4 and 6. You wouldn't do 24. It would be 12. And you would multiply them by different numbers, not each other. Okay, so you put terms over the LCD, least common denominator, and then use the following property for fractions. What is that said following property? It's not in my note outline, so I need to find it real quick. Oh yeah, we talked about this section. So on. Oh yeah. It's just that A plus C plus B plus C equals A plus B over C. Just like 1/4 plus 1/4 is 2/4, which reduces to 1/2. But if I add 1/4 and 1/5, it's not going to be 2/20. That's smaller. Okay, and then again, oops, oh my goodness, technical issues today. Okay, there we go. We just need to specify that C cannot be 0 because we don't like dividing by 0. Okay, so add and then simplify. So when we're told to add them together, before we add, we need to find the least common denominator. Denominator, we do that again when we're multiplying things. So what's best to do, in my opinion, is to go ahead and factor everything, specifically the denominators. All right, so x over x plus 1, both of those are irreducible. And 2x plus 3, we know that's irreducible. X squared minus 1, I think we just saw that's a difference of squares. So it's x minus 1, x plus 1. Okay, great. So now I know that my least common denominator, I'm not going to multiply x plus 1 times x minus 1, x plus 1, because I already have x plus 1 in each of them. So my least common denominator is actually going to be this guy, this x minus 1, x plus 1. So if you want to go over here and just kind of write least common denominator, x minus 1, oh, okay, x plus 1, x minus 1. All right, and this helps because sometimes you might have to add more than two fractions together. So it's good to keep track of your least common denominator. Okay, great. This fraction right here, he has all of them. So I don't need to multiply by anything. This first fraction though, he has only x plus 1, so he's missing this one. So we're going to multiply by our fancy 1. So fancy 1, she'll be in purple, will be x minus 1 over x minus 1, right? So then I'll get x minus 1, x minus 1, x plus 1, plus 2x plus 3, x minus 1, x plus 1. Beautiful. Great. Now both of my denominators are the same, and they are my least common denominator, which is helpful. If you don't do the least common denominator, you will then have to simplify at the end, because you'll have another factor in the numerator from multiplying by a fancy 1. So you'll just have to do an extra step. So it won't kill you, but it might make your life a little harder. And a crunch, it will take you a little bit more time. Okay. So I'm now ready to add. So I'm going to have x minus 1, 2, oh, not times, plus 2x plus 3. If this was a subtraction sign, it would be like minus this in parentheses, like that. Oh, I think I have an example afterwards. All right, and then my denominator is this guy, x minus 1, x plus 1. Okay, so I'm now going to make sure that I can't simplify anymore. I can't cross out x minus 1, because not every term has an x minus 1 in it. 2x doesn't have an x minus 1, and 3 doesn't have an x minus 1. So I can't cancel it out. It's only a factor of this first term in the numerator. So what I'm going to do is I'm actually going to distribute this x. So I'll get x squared minus x plus 2x plus 3 over x minus 1, x plus 1. And then that'll give me x squared plus 1 plus 3. So not plus 1, plus x. X minus 1, x plus 1. So then did I write the problem wrong? Oh my God, I wrote the problem wrong. Why didn't anyone tell me this is x minus 1? So that changes this to be plus and then a plus. That's an easy fix though. And if you did this, then you did all the things right. X plus 1 plus 1 plus 1. Okay, so then that would be a 3. I'm so sorry about that, but everyone makes mistakes. Okay, great. I can't think of anything that multiplies to 3 other than 3 and 1. It's a prime number. And that obviously does not add to 3. And we only factor into whole numbers. So I think we're done. I don't think I would say this is irreducible. And we're done. But if we had a case where this was like maybe 4 plus 4 instead of plus 3, then we could have factored and maybe one of them would have worked out. I don't know. All right. Now we'll talk about subtraction 1. So sometimes when I see a squared, when I'm working on these problems, I like to write out each factor on their own. So I would write like this is like, oh, x plus 1, x plus 1, right? And I know that birds are chirping outside. It's so cute. I can't have just x plus 1 in my least common denominator, right? I can't have something smaller than what each one of them has. It would be like saying that the least common denominator for like 2, no, for 4 and 6 was 2 because they both have a 2 in them, but like that's not true. So we're going to have x plus 1 and x plus 1 from that being x plus 1 squared. So then let's go ahead and factor this first denominator. I can't factor 1, it's just 1. X squared minus 1, it's like our favorite difference of squares, minus 2. And then if you want to write it like I do, you can write x plus 1, x plus 1. All right, so each one of them has an x plus 1, right? So this guy is satisfied, great. But I also need another one, and then this has an x minus 1. So I'm going to tack that onto my, that's why I like writing my least common denominator on the side. So as I work through factoring the numerators and denominators, I can keep track of them. I love organization. I'm a Virgo sun. So what do I need to multiply my first fraction by? I think I need to multiply it by, I have an x plus 1. I have one of them, and I have one x minus 1. So I need to multiply by an x plus 1. So where's my purple? And I wrote the question right again. Okay, yeah. And then for my second fraction, I have I just have these first two guys. So I have this guy and I have this guy. So I need to include an x minus 1. Okay, so my first fraction, remember just multiplying fractions, I get 1 times x plus 1, x plus 1, x plus 1, x minus 1. Usually I like to write my denominator first because I like to be centered. There we go. And then if you want to add 1 times, that's also fine. Minus, and then x plus 1, x plus 1, x minus 1. Oh, x plus 1, x plus 1, x minus 1. To x minus 1. Great. And we can see that both of these match. So double checking that our least common denominator was the actual truth. So good to go. So now I'm going to do x plus 1, and this is where the subtraction comes in, minus 2x minus 1. So that minus gets pushed up to the numerator when we pull those two fractions together. So x plus 1, x plus 1, x minus 1. All right, and so we can distribute this negative 2 to each x and x minus 1. So I'll get x plus 1 minus 2x. Minus 2 times minus 1 is going to be plus 2 over, I'm going to write x plus 1 squared just to save myself a little bit of time, x minus 1. And then I'm going to combine these things. So what's that going to look like? That's going to be x minus 2x, so minus x plus 3 over x plus 1 squared, x minus 1. And we know x, negative x minus, or sorry, plus 3, that is irreducible. X plus a constant or something times x plus something else that is not divisible by the coefficient in front of x, that's going to be irreducible, or else I can pull out something. All right, and we're done. Ta, we did it. So we're getting even more practice in factoring, which is really, really great because B.2 was a lot. So we can kind of kill two birds from stone, practice on our fractions and practice with our factoring. Okay, so with multiplying things, like multiplying rational expressions, comes another tool that comes from that. So we did learn factoring so that we could do rational expression simplifying rational expressions, which helps us do what is called rationalizing the denominator. So if a fraction has a denominator of the form, let's say like a plus b square root c, we can rationalize it, i.e. move the radical to the numerator. It's improper to have a radical in the denominator. I don't know why. I didn't make these rules. I think it has to do with some number theorist having a high horse. I don't know. I'm just an applied mathematician. Okay, so we can move the radical to the numerator. So like it would look something like this first example, right? 1 divided by 1 plus square root of 2. We don't really, like, it's kind of weird to look at, right? So we can move that radical to the numerator by multiplying what is called the conjugate, which really reminds me of that scary movie where like the hands came out. They're like terrifying, absolutely scary. I love scary movies. My boyfriend hates them, but he tried to convince me once that he liked them. Didn't make it first 5 minutes. All right, and that conjugate, all that's happening is I change the sign that's in there. So that's an addition. So the conjugate is going to be a minus b square root of c. Duke has the hiccups. So if it was the conjugate of a minus b square root of c is a plus b square root of c. And this only works with square roots, okay? Oh my God. Are you okay? Go get some water. It doesn't work with any cube roots, and we'll talk about why in a second. All right, so let's work on this example. So I want to rationalize 1 over 1 plus square root of 2. So all the conjugate of 1 plus square root of 2, I'm just going to switch that plus to a minus. So the conjugate, it's like we're in Spanish class or some language class. I only took Spanish and Latin. Would be 1 minus square root of 2. So we multiply by the conjugate. Okay, so that is kind of multiplying by the conjugate. Remember, we can only, without changing the fraction, I need to multiply by fancy 1. So the fancy 1 is using the conjugate. I'm not asking you to just multiply by 1 minus 2 because that's going to go into the numerator. That's silly. So I'm going to take 1 plus square root of 2, use my fancy 1 color, dusty purple. It's going to be 1 minus root 2 over 1 minus root 2. So then 1 times 1 minus root 2 is just 1 minus root 2, and then 1 plus root 2, 1 minus root 2. So does this look like familiar to anything? Something plus something, something minus something. Just gonna let that set in for a little bit. All right. So then when I FOIL the denominator out, 1 times 1, so 1 plus root 2 minus root 2, and then, no, what, minus root 2 squared. And that simplifies to 1 minus root 2, 1 minus square root of 2 times 2 is just 2. Okay, and I'm not done simplifying quite yet. Get 1 minus square root of 2 over negative 1. And we can kind of simplify a step further by multiplying that negative 1, because negative 1 is just 1 over negative 1, negative 1 over 1. It's like the negative can float. Spooky that way. So then that negative can distribute to the 1 and to the root 2. So we get negative 1 plus root 2 over 1, which is just the same as the numerator on its own. Okay, and that's what we called rationalizing the denominator. And I said this only works with square roots. Why? Because this resembles the factoring of, what is it? Difference of squares. Okay. I film these after I go to the gym and I'm always in a little bit of a brain fog after that. Of squares. Squares, right? And you can see that. 1 and, well, 2 isn't a square, but the square root of it is 2. Square root 2. Wouldn't that be wild? Oh, that's 1. And be like, what if something is the square root of itself? That's like 1 and 0. So it's not that as exciting because there's 2 numbers that do that. I wonder if there's another number. No. So it only works with square roots because of the difference of squares. When we have difference of cubes and sum of cubes, I would have to find like it would be like if this was like a cube, but I wouldn't have a conjugate that looks so nice. It would be different. So think about what that conjugate would be. I think it'll be pretty interesting. Okay. So I think that's all for this one. I'll give you a little aside is think about what the conjugate of like 1 plus cube root 2 would be. I'm going to put conjugate in parentheses because it doesn't really exist. It does exist, but not in the sense of what we just talked about. So I don't want you guys to get confused. Okay. All right. I think that's it. So I'm going to end this recording now and I'll see you tomorrow. Have a nice day.